Good morning, my dear students. Welcome to Science Classroom. Yesterday we were dealing with fourth problem of our exercise, chapter electricity, and I just given the ratio. I'll give you the explanation of that one. And the question is, two conducting wire of the same material and of equal length and equal diameter are first connected in series, then in parallel in a circuit across the same potential difference. The ratio of heat produced in the series and parallel combination would be, we have to find the ratio. I given the ratio as 1:4. So let us, I'll give you the explanation for that. Let RS, excuse me, let RS be the sum of RS and RP be the equivalent resistance. Resistance of resistors when connected in series and parallel. For RS for series and RP for parallel. For same potential difference, difference V, the ratio of we have to find the ratio of heat produced. The ratio of heat produced in the circuit. Produced in the circuit is given by Hs by Hp is equal to, that is heat in series and heat in parallel, V square by R square into T by V square by Rp into T this is not R square, this is V square by Rs, that is resistance in heat in series and heat in parallel, that is V square by resistance in series and V square by resistor in parallel into T. That we will get Rp by Rs. The ratio we will get. The ratio of the heat produced in the circuit we will get as Rp by Rs. Then the equivalent resistance of resistors connected in series that is Rs is equal to R1 plus R, that is 2R. Then the equivalent resistance of resistors connected in parallel is Rp is equal to 1 by R1 plus 1 by R2. 1 by R, which will give R by 2 as the answer. R by 2 as the answer. Then the heat produced in series and parallel combination. Hence, the heat produced in series and parallel combination would be HP. We earlier seen HP by HS. That is equal to 2 by 2R. 2 by 2R, which is equal to 1 by 4. Okay. So therefore the ratio is 1:4. Okay, this is the explanation for our last question, and let us go to the next question. What is our next question? How is a voltmeter connected in the circuit to measure the potential difference between 2 points? Our fifth question. The answer is to measure the voltage between any 2 points the voltmeter should be connected in parallel. Connected in parallel between the 2 points. So the fifth question is over. And what is the sixth question? A copper wire has diameter 0.1 resistivity of 1.6 into 10 raised to 8 ohm meter. What will be the length of this wire to make its resistance 10 ohm? How much does the resistance change if the diameter is doubled? So we want to find what will be the length of the wire to make it resistance 10 ohm, and also how much does the resistance change if the diameter is doubled. So let us see the answer for that. The resistance of the copper wire. Okay, we will in next part we will do the solution. So the resistance of the copper wire, the solution, the resistance of the copper wire of length in meters and area of cross section m square is given by the formula R is equal to rho L by A. The area of cross section of the wire can be calculated as follows. That is, A is equal to pi into diameter by 2 all square. Then we are going to substitute the values in the formula. Substituting the values in the formula. That is, L is equal to RA by rho, that is 10 into 3.14 into 0.0005 whole square by 2 by 1.6 into 10 raised to minus 8. We get 10 into 3.14 into 25 by 4 into 1.6. You get the length as 122.72 meter. You get the length as 122.72 meter. Then, if the wire is doubled, what will be the resistance? First answer we got, and if the wire is doubled, the new diameter will be previously 0.00 previously it was 0.005 and now it will change. If it is doubled, 0.001 or 1 mm. So the resistance. Therefore, the resistance can be calculated. How to calculate the resistance? R is equal to rho L by A. That is 1.6 into 10 raised to minus 8 into 122.72 by pi into 0.001, that is the diameter, square by 2. We get 250.2 into 10 raised to minus 2. That is 2.5 ohm. The resistance, if it is double, is 2.5 ohm. Then let us go to the next question. Just seventh question. The values of current I flowing in a given resistor for the corresponding values of potential difference V across the resistors are given below. I in ampere 0.5, 1, 2 and 3. V volt 1.6, 3.4, 6.7, 1, 10.2. Plot a graph between V and I and calculate the resistance of that resistance. Okay, let us go through that. The plot between voltage. The plot between voltage and current. The graph which we are plotting between the voltage and current is known as I V characteristics, and current is plotted in y-axis current I is plotted in y-axis and voltage is plotted in x-axis. Then the table, let us draw the table also. That is current I in ampere, voltage V, which are the values? 0.5 for that, 1.6 and 1.0 and 3.4, 2.0, 6.7, 3.0, 10.2. These are the values given. Let us plot the graph. Okay, here we are going to plot the graph. Y-axis current, x-axis voltage, 0 is there, and we'll take the unit into 4, 6, 8 and 10. And the current is taking in one unit, 1, 2, 3, 4 and 5. And first point, that is between current side 0.5 and voltage side 1.6, that will come somewhat here, first point. And second one, that is current, that is 1, and voltage, that is 3.4. 3.4 will come and it will meet at a point here. And third one, 2.0 is the current, and the voltage is 6.7. That will come somewhat here. It will come somewhat here. The point is this one. And next is 3.0 and 10.2. We'll get a point somewhat here. Okay, the graph is plotted. And we are drawing one slope. We are drawing one line. Okay, and we are connecting it with the dot and marking the point B, and here we are marking, this is 10.2. And one more we are marking between second value, which is A. And the solution, the graph is plotted. The solution for this one will be given in your next class. Already the video won't upload, so I'm stopping. Thank you so much. Okay, let us, what is next? The current and voltage is given. We have to find out the resistance from the graph. So we have drawn the slope. Okay, drawn the slope and mark the point B, A, B, C. Okay, we have marked the point A, B and C in the graph. Okay, so we will get the slope. The slope of the line. Okay, the slope of the line gives the value, of resistance. The slope can be calculated as follows. How we will calculate the slope? That is, slope will give resistance 1 by R is equal to BC. BC, this is BC. BC. And this is the BC. BC by AC. This is the AC slope. Okay. BC by AC. So we want to find the value of BC and AC. How we will find? You see, what is the value? In the case of, we are finding current. Okay, in the case of current, we are finding the B is equal to 3. Okay, B is at the point the current at point B is 3, and the current at the point C is 1. See, the B, which is the last point, that is 3, and current at the second point, that is 3.4 is 1. So to find the value of BC, that means this one is 1 and this one is 3. So 3 minus 1, we will get 2 ampere as current. The value of BC is 2. We got 2, which is equal to 2 by, and we have to find AC. Okay, and what is the voltage in C? Voltage in the case of C, that is 10.2. We know that. This is the last point, which is C, 10.2. And what is the case of A? A, 3.4. A is, which is the 10.2 is the voltage at C, and 3.4 is the voltage at A. So to find AC, we can substitute, or we can subtract the 3.4 from 10.2, then we will get 6.8 volt. That is, we will write here 2 by 6.8. Then here 1 by R is equal to 2 by 6.8. Then what is R? R is equal to 6.8 by 2, that is 3.4. The resistance is 3.4 ohm. Okay, did you understand? And this is the resistance which we got from the graph. Thank you so much.